Okay, so let's proceed to 3D modeling. 3D modeling, as I said before, it is more artistic than computer-aided design. Means that you have a bit more freedom to create your 3D models. So early research stems from the same basic research, like we've seen with Ivan Sutherland's thesis and Sketchpad. And we can say that in the 70s there was really a push in terms of development of computer graphics like we know them today. And a fun fact is that there was a Vietnamese PhD student in the University of Utah that was really one of the main focus of computer graphics research. That is Bui Tung Phong, that in 1973 wrote this algorithm in order to create this sort of smooth shading and also this specular reflection. So it is really interesting, and if you want to know a bit more about Phong reflection, you might go to YouTube to see some videos or to Google. Also, there was, of course, these basic building blocks that as we know them today and that we are going to learn in this class, that were developed, most of them in the University of Utah. Here we see the work of Edwin Catmull, that was then the former president of Pixar and also Walt Disney Studios, and he invented texture mapping. So texture mapping is the ability of putting a 2D image onto a 3D virtual object and then wrap it around. And Edwin Catmull was the one that developed that sort of technology. Also, in terms of realistic 3D shapes, we owe too much to Martin Newell, that he created the Utah teapot. That is this teapot that was constructed using Bezier curves. Bezier curves is a type of curve that was used in the aeronautical and automotive industries, and he created this sort of object in order to study different parameters that were only achieved if you have an object with a certain degree of complexity. And you can see nowadays in pop culture many references to it. So here we can see in Toy Story, the first feature film, long feature film of Pixar, that you have here the Utah teapot. So a reference to that. So the outcomes of 3D modeling. You can do models for animated movies, for visual effects, also commonly known with the acronym of VFX, architectural visualizations, gaming environments and characters, and also, of course, assets for augmented reality or virtual reality, and also 3D printing. I know that I referred that computer design was mostly used for physical products, and here we have that that 3D modeling can be used also for 3D printing, which is, of course, a physical product, but it has a different degree of complexity than products that are machined. So 3D modeling. 3D modeling is usually commonly known as well with polygonal modeling, which is a way of working and sculpting in that it's like you are working with clay. You have a mesh, and then you edit the polygons of the mesh and the vertices and edges in order to achieve the desired shape. So this slide is, of course, what we are going to be focusing on this course. Okay, so we also have digital sculpting. Digital sculpting is something that sometimes it is known as 2.D modeling, meaning that there are some tools that come from 3D, but there are also some tools that come from 2D, like 2D applications like Photoshop, meaning that you can sculpt with brushes, you can do the texture as well as you are creating the 3D model. So it is something that enables you to sculpt and create some textures, and it's something that is quite interesting. It's not the main focus of this course, though. We also, when we are creating a 3D model, we want to texture. So texture is the ability of putting 2D images wrapped around the 3D model in order to be able to get some more realistic level in the end. So we have this is UV mapping, that is the ability of setting up how those 2D textures are going to conform into your 3D object, and it is called UV. UV is the coordinate system of that defines how the 2D map is going to be wrapped around the 3D model. Then, of course, we have lighting. Lighting enables you to define how the light will be casted on the different surfaces, different digital surfaces that you have created, and how the interplay between light and shadow will create, in this case of the image, a realistic image, but also other types of images. And in the end, we have rendering. So rendering is the major output of 3D modeling, meaning that you have your 3D creation that is in which you are setting that all those parameters inside the 3D modeling application, and then you want an output, meaning the output can be an image, can be a sequence of images, like an animated movie. So in order to do that, that is called rendering. That is the process of generating an image out of the 3D modeling. So it can be realistic or can be non-realistic. So you can define your own style as well. So of course that is an interplay between modeling, between texturing, lighting, and you need to know a bit of all of that in order to proceed. This course will be focusing on polygonal modeling. So if you have a solid foundation in modeling, it is also easier to integrate different teams and integrating a 3D pipeline, and also, of course, progressing onto texturing and lighting in a deeper level. So common software. We are going to focus on Blender. But these are common software that are used across the industry and across many industries, like I've referred previously: architectural visualization, visual effects, animation, and so on. So you would encounter these objects if you apply to different companies. The thing is, if you have a solid foundation in what 3D modeling is, you can jump across these platforms, and it is of course normal that you do that within your professional journey. Okay, so we are going to focus on Blender. So check the description to understand how you shall download it and install, so we can start on the next video. Okay.